Okay, my outstanding friends, we've got a new sort of situation going on. I have been claiming all of these fields need to be looked into. Geology, biology, atomic physics, light, space, history, archaeology, anthropology, our origins, everything. So we need to do Zoom question and answers and discussions, and I have set up a Zoom account. It's the one that you don't have to worry every 40 minutes you get an extended time, and I think I have 100 people or so on there now, can have that many. Now, I'm going to start getting deep into Twitter, and anybody that makes statements about things like black holes and so forth, I am going to Twitter them and ask them to look at my research. So please follow me at GSRG Group, GSR Group 10. You know, that's on Twitter. And my email is going to be gsrgroup10@gmail.com. Now, what we need to do is study all of these things, every single thing there is, all this stuff, 100%. And that's what I'd like to start today. Okay, so let's just start with this. You know that I want to use this Warren effect, which accelerates light and creates fission and fusion, which is exactly what CERN and Fermilab want to see, is the muons and electron showers, and here they are. They claim to do this, we can get trillions of electron volts. If that's true, we should be able to harvest those excessive electron volts in a device like this using a small amount of energy to create a large amount, and then just using some of that to continue the process, harvesting the rest as free energy. And I claim we can do that right here, right now, with things that are off the shelf, with a little bit of engineering from the California laboratories, although they're, because Governor Newsom is talking about pulling all the stops out to try to work on global warming, and this is one of the stops he could pull. Now, this is not pie in the sky. These are the two smallest particles they can see at Fermilab and CERN, which is a muon, basically, and an electron neutrino. And they can see them, but they didn't know where they came from. They come from light. And we split these two and divided them to create fission. And then when they came back together, that's fusion. And here's that event actually occurring right here. By accelerating them, using the Warren effect to split them, we created the white shower, which is the electron neutrino electron shower, and the sterile muon, which is this right here. So these are their drawings. These are our actual experimental data. All right, now again, I don't know much about this stuff, but the way I understand it, Twitter, I can just sort of post up there, you can follow me, and I could tweet up there something about we're going to have a meeting at 2 o'clock on this Zoom code number. And at 2 o'clock, everybody can go up there and we'll talk about and discuss whatever the topic of the day is, or anything you want. I don't care, because everything has to change now. I mean, literally everything. At least we have to look at it. Let's go with that and start there. Now, let's think about this for one last second. And don't forget, this is how you get a hold of me. Now, if we could get free energy using these extremely inexpensive devices, once you build them, they just keep running. They're solid state. There's nothing really to go wrong, hardly. They'd have to be built durably, and then you could carry them around. Something like this. You could carry that into the woods and have all your different types of outlets, AC, DC, 120, 220, 50 cycle, 60 cycle, I don't care what I do. And then you just have a couple of little switches or beep, 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 and it just takes off and goes. And if we can get the kind of energy they're talking about, which is they're talking trillions of volts, and they did get it. After they upgraded to do what we were doing, which is focusing at CERN, they are getting these trillion volt levels. Okay, this is the Large Hadron Collider. They just restarted it after 3 years shutting it down so that they could focus the beams and hit them head on and get a lot of collisions. And they do. But all it is a big explosion. These are all those little white particles going flying. And they have no really a big idea of how they cause this reaction. All they know is they have broken apart protons. And these are the particles they're seeing. Now they're going to dig through them and see if they can make any sense out of it. And I can make sense out of it right now. They will never see the dark matter. All they're going to see is the white particles because they're hitting them head on and just having an explosion like this way. We're squirting them through and separating them and can see them. They have them all intermingled and they may never ever see them. I don't know. Now, I'm not making any claims that they did this because of me, but I can tell you what. We were doing this in 2015. I had finished all of my research on the Warren effect and how it split the particles, and I presented to everybody. And then I ended up going to University of Geneva, and I told them, you need to focus them to make them split. You guys are just hoping something's going to hit. And then the next thing I know, well, not next thing I know, but I heard they shut down. And then when they opened back up, it was the improvements in the injector complex. What happens is they needed to focus them down to tight beams and hit them head on. Now, I don't think they even need to hit them head on. If they focus them in a tight beam, they're going to squirt out the same stuff we're squirting out, which is muons and electron showers. All right, see, here it is right there. They're trying to work up to this 13.6 trillion electron volts from, let's say, a couple of 100 million. Who cares? If we can get up to trillions, that's a huge increase. Now, and this is what it is right here. It says they can expect 50 times increase in the total number of recorded ion collisions thanks to the recent completion of a major upgrade, and that's the focus. It's an unprecedented number of collisions will allow international team of physicists across the world to study the Higgs boson in great detail and put the standard model of physics to its various extensions to the most stringent tests yet. Well, I already have, and they have failed. I'll show you they failed. All right, don't forget, they're coming head on, or this way, coming, but whatever, they're just getting this big splash of radiance coming out because of this impact of these energetic masses. It's mass to mass. Now, here's what we got. We sent that tiny little particle, which was nothing more than a light particle, but everything is made from these two little particles, this muon and electron neutrino. These two make everything. And they glue together just like this, one and the other. And when you only have one of each, a muon and electron neutrino, that's what we would have always considered, these two right here, together. We would always consider that electron. That will burn you. It's sparky, it's static, it's lightning, it's electricity, and it wants to go to ground because there's more dark energy in ground, I believe, than there is white. So they really want to go to ground. That's why electricity, you run it to ground so it won't go through you. It will just go to ground and save you from being electrocuted. Now, two of these electrons together make the photon, which we have seen. Now, CERN has seen identically the same particle in Fermilab. However, they see them broken up. So sometimes they see these two together. Sometimes they see all four of them together. Sometimes they see 6 or 8 of them or 10 of them together. But the small packages of them, the smallest ones they can find, they're looking for the tiniest ones, and they have found them, the black one and the white glowy one. And here it is right here. This is Fermilab and CERN. That is not my drawing. That is from Fermilab, and it's from 2013, Don Lincoln's discussion about a fixed black particle and a glowy little, almost massless particle. There they are. Now, we need to use this energetic separation of powers because here's what it creates. It creates enormous quantities of electricity. You see, this visible light is only in the 3 to 5 electron volts. If we were using high-powered lasers, even at alpha particles, which are killers, it's only 10 megavolts. We're in the trillions of volts, the stuff I just showed you. If that is actually factually true, we should easily be able to put a device just like this, solid state, harvest as much as we want, put this little package in a box like this, put them in cars and boats and planes and little packages you carry them out to a camp out in the woods or go whatever you want, lighting and heating, air conditioning, all for free, absolutely 100% free. Once you build it, it should run and never have to, that's it. You know, you might want some battery backup, but once it's going, it should be able to produce enough energy to maintain itself. You need something to kick it off. It's like a starting capacitor. If you don't have something to kick it off, it's never going to run. But once you kick it, boom, she takes off. Now, I'm just using that, kidding around about the starting capacitor. But something like that, we may be able to fix the world. Third world countries, you know, they need everything just like we do. And they have no infrastructure. They just need something that they can walk around like this, plug their devices into it, and have electricity anywhere they want without polluting, without anything wrong with that. Not a single thing would that cause environmental damage. We're down in the subatomic range. Only things that are big chunks and that go long distances will hurt you. And those are the alpha particles and all of those really atomic broken parts. We are in the sub atom range. We're down in the electron range, which is light particles. You know, we're putting them on steroids for an instant and then they come back. Now, if you can get in between that instant, I think you can use them to really do some serious work. Because we saw the glow, and when you see glow, you know that's energy. All right, I'm going to leave it at that. I'm going to show you something. This is a simulated Higgs event where they come and smashing particles head on, and one smashes all these little rays this way, the other one smashes all of them that way, and some of them go this way and some of them go that way. But the thing is, it's a huge collision here. And then they see these Higgs fields show up out here. Okay, well, and then they look for the tiniest particles. Well, we did these sprays, and that collision right here. And where did I show you the collision we get? These are the Higgs fields, these little circular fields they got. We shot it right here, and as soon as this splash hits, it slows down and it becomes Higgs fields. It's stunning. Check this out. Remember I told you we're coming through here like a rocket ship? Look at this. This is when these Higgs fields are created, and they are created at an exact certain distance from the acceleration point, where this slows down just enough to impact with all the fields, because these are nothing more than fields. These are not particles. There is a particle, I believe, in the center of every one of these fields. And we slowed this, well, let me show you what Fabian did. Because we got some unbelievable shots here. I know, they are unbelievable, but they're real. And that is the Higgs fields on steroids. That's all I can tell you. Now, wait till you see this. All right, you saw those round circular fields. They pop up right here, right there. And they are the Higgs fields. And that is because this particle, the white one, smashes into the black one and they become a unit again. They fuse back together. Originally, they were fused together here until they separated at the venturi here. So the black separated from the white right there. That's a fission. After the venturi, they immediately came back together here at an exact certain distance out. Right there, you see it? And in between there, I believe, is where we want to be able to harvest our energy from. So I would like some of these people on Twitter making their claims to discuss the things with me. And not only do I have that, I have a lot of other stuff. And I want to engage. And this is how you get through to me. Twitter, you know, follow me on Twitter. And that's the group. And this is my email. And it's everything, we're going to talk about everything. But right now, this is the most important thing. We get free energy. We can fix the world. And I mean, this stuff is on the shelf. This should be able to be done literally overnight. If this was hit like a SWAT team, we'd get this done. And if Governor Newsom is sincere to his words, he says he's going to hit it like a SWAT team, and they want something done right away, at least talk to me. Within a week or a month, we'll know one way or the other, is this anything that's even possibly feasible? They've been going for 89 years trying to find dark energy. 89 years. They had a special commission in 1978 to see if they could use the Large Hadron Collider as a photon collider, which this is it. This is it. We don't have to hit them head on. We crush them. We crush them. We crush them. We don't have to hit them head on. They're using the Casimir effect. We're using the Warren effect. Field to field, doesn't matter. Field to field head on, same thing as field to field sideways. And you have to force it through that little tiny slit, and that's what created this enormous increase in energy. And I think we're missing the boat if we don't get started right away. Okay, let me explain something to you. This goes back, like I say, quite a long time ago, and it was a fellow named Fabien Boulay, and he travels around the world, I believe. And we sent him a bunch of pictures because he could enhance them, and he did. And in fact, look at this. You see that? That is actually these fields. And I don't know how he does it. I have no idea how he enhances them so well. But he's also the one that can show the photons glowing and the black particles and all that in exquisite detail. Now, what are we actually seeing here? This is outward. So I drew a little thing like this, and they kept it. Look, they're in these 6-packs. I would have expected 8, but there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6, 6, 6, 6, and they all hook together in 6s. And this is what you'd really see if you were looking at it from the side. You'd see a bump sticking out, and these are the ones that are impacting, which are these are positive and negative particles, just like a little tiny bar magnet. Nothing different than that right there. All right, you see that little particle? That's exactly what it is coming at us. All right, now these lead, and it pushes this. It looks like the dark matter is coming out ahead of the white matter. I don't know. These are valleys, and I don't know what else to say. It's just pretty stunning, I gotta be honest with you. Now, this was Fabien took Rod's particles and he enhanced them here. You see, when I first looked at that, I really couldn't tell any difference between these two whites, and the blacks are the same, so the blacks didn't change. But the two whites are totally different. This one's very glowy, and if you take your time and just sit back and think for a second, or look at it, you can see this is much more glowy. And the reason is because of this interaction right here. You see? These little tiny particles, I hope you can see them. Sometimes they're hard to see. You see them? That little particle right there is banging into those little red ones, which are nothing more than other particles, which have fields. Fields pushing against other fields create energy. Energy creates light. Light is nothing more than an increase in mass. It literally is. The more brightness is the more mass. It's impacting harder. Mass is nothing more than impact. So even if you had like a little tiny thing that weighed an ounce, but it was going 1,000 miles an hour, you're really going to have some serious mass. If you had that 1 ounce thing here and you dropped it, well, that's it. There's no big deal there. But if it was going 1,000 miles an hour and hit you, yeah, that's a big deal. All right, so mass is energy. Einstein's c² is absolutely meaningless. Energy equals mass. All right, that's exactly all it is. And mass increases with movement. So this right here, with a resting mass, might be 1 ounce. But when it's going 1,000 miles an hour, it could have a mass of 1,000 pounds, 2,000 pounds, who knows? Because that's the energetic value. So mass is not something to do with you put it on a scale and you say, oh yeah, that's its mass. No. It's only one of the factors. It says, what is that thing hitting into? If it's hitting a mushy thing and it's bouncing real soft back, it takes away from its mass. If it's hitting a hard object and springing back like a rocket ship, well, that's an effect on its mass. It's not as quite simple as it seems. But I can tell you right now, when they smash particles apart, the protons, that's the smallest particles they see. And as far as I'm concerned, they make up these particles here. When you start to have two of them together, then you end up with photons, and then they grow up from there to be the first semi-stable particle, which is hydrogen, is about 1835 of these two particles together. The two of them together is just like a bar magnet. They don't fall apart easily. The only way we could make them fall apart was the Rod-Warren venturi, caused the Warren effect. And that's how we divided them. Now, it was just accidental good luck. Let's harvest some energy if we can. It'll only take a couple of weeks to find out, and then it'll only take a couple of weeks to have it actually in service.